Good day everyone. Today I'll be discussing industrial plant engineering prelim problem solving. So let's start. For problem number one, a boiler house has a natural grout chimney of 20-meter height. Flue gases are at a temperature of 380 degrees Celsius and ambient temperature is 27 degrees Celsius. Determine the grout in millimeter of column for maximum discharge throughout through chimney, having also the air supplied per kilogram of fuel. So for the given atay H is equal to 20 meters. Ato ang temperatures of flue gas is equivalent to 380 degrees Celsius plus 273 para mahimo siya og 653 Kelvin. And then sa atong air 27 plus 273 is equivalent to 300 Kelvin. So for the solution, letter A ta mag-start ta. I-determine na to ang drought. So H is equal to 353 times height times 1 over 2 T air. Substitute na to na siya. 353 times 20 times 1 over 2 times 300. So naatay H is equivalent to 11.767 millimeter of water. And next, sa letter B, itong ginapangita kay supplied per kilogram of fuel. So, another formula, H is equal to 353 times height times 1 over 2 times T of air minus M plus 1 over M times gas, temperature gas. So, substitute nato ni ay ano na siya? Transpose ang 353 o ang height. So, yun na siya mahitabo. So, yeah, M plus 1 over M times 1 over T gas is equal to 1 over T air minus H over 353 times height. Reciprocate na po, M plus 1 over M is equal to 1 over T air minus H over 353 times height times temperature gas. So, substitute na to na siya. So, naatay M plus 1 over M is equal to 1 over 300 minus 11.767 over 353 times 20 times 653 temperature gas. And that siya din may equivalent siya to 1.0883 meters. Then, ship solve na lang dayon. Okay, para makuha na to ang M or mass ba na to. This is equivalent to 11.325 kilogram of air over kilogram of fuel. So, next, problem number 2, determine the temperature of hot flue gas. Hot flue gases natural drought supplied produce and efficiency of chimney for maximum discharge through chimney having height of 80 meter. A boiler furnace is supplied by a 20 kilogram of air per kilogram of fuel. The minimum temperature of hot gases with artificial drought is 110 degrees Celsius. A temperature of surroundings is 27 degrees Celsius and specific heat of flue gases is 1.0032 kilojoules over kilogram per Kelvin. So para problem given aning problem kay naatay height which is equivalent to 80 meters. M is equal to 20 kilogram per kilogram of fuel. Natin artificial temperature is equivalent to 110 degrees plus 273 para may mo siya og 383 Kelvin. Same yapon sa air, add lang ta og 273 para may mo siyang 300 Kelvin. Yan atong given nga flue gas specific heat, which is 1.0032 kilojoules per kilogram Kelvin. So for the solution, kanitong gamiton T-gas is equal to 2 times m plus 1 over m times T air. Since na naman ta ni ito na sa ipag-substitute. So 2 times 20 plus 1 over 20 times 300. So natin temperature gas which is equivalent to 630 Kelvin. So very simple na yun. And then for letter B, H is equal to 353 times height times 1 over 2 times the air. Substitute lang na yan. So 353 times 20 times 1 over 2 times 300. Parenthesis. Na H na is equivalent to 47.0667 millimeter of water. And then for the letter C, H apostrophe is equal to H is equal to 80. So efficiency of chimney is equivalent to 9.81 times H times 1000 times specific heat times temperature gas minus artificial temperature times 100%. Okay, ano man siya efficiency mo siya. So substitute lang 9.81 times 80 over 1000 times 1.0032 times 630 minus 383 times 100%. Na tayo final answer na efficiency which is equivalent to 0.32%. More na siya, very simple. Next, number 3. A boiler may have waste gases leaving the installation when artificial draught is used at 150 degrees Celsius. The natural draught chimney is of 60-meter height. The hot gases within the chimney are at a temperature of 300 degrees Celsius, and air requirements is 19 kilogram per kilogram of fuel burned. The atmospheric air is at 17 degrees Celsius. Temperature and mean specific heat of hot gases is 1.0032 kilojoules per kilogram Kelvin. The caloric value of fuel burned is 32,604 kilojoules per kilogram. Determine A, the draught produced in millimeter of water, B, the efficiency of chimney, and C, the extra heat carried away by flue gases per kilogram of fuel. So, given a problem, H is equal to 60, temperature air, 290 Kelvin, temperature gas, 573 Kelvin, temperature, artificial temperature, 420 Kelvin, mass, 19 kilogram per kilogram of fuel, mg. So 1 plus 19, so natin 20 kilogram per kilogram fuel. Yung specific heat na to 1.0032 kilojoules per kilogram Kelvin. Atong caloric value which is 32,604 kilojoules per kilogram. For the solution for letter A, the draught produced. So H is equal to 353 times height times 1 over T air minus M plus 1 over M times temperature gas. So substitute lang 353 times 60 times 1 over 290 minus 19 plus 1 over 19 times 573. So natin drought magkakaproduce which is equivalent to 34.12 millimeter water. So sa letter B, H apostrophe is equal to H times M over M plus 1 times T gas over T air minus 1. So substitute lang yapon. 60 times 19 over 19 plus 1 times 573 over 290 minus 1. Natay answer dayon anak nga sa 52.62 millimeter. Yes, sakto. Then, after that, kuha na itong efficiency which is 9.81 times H apostrophe over 1000 times CP times T gas minus T artificial times 100% since efficiency man siya. So, substitute lang. Kumaman na we will have a final answer sa ato ang efficiency which is equivalent to 0.34%. And then lastly sa ato ang letter C, ang extra heat carried away by the flue gas. So mg minus specific heat times mg times specific heat times T gas minus T artificial. Since itong mg is equivalent to 20, times multiply na ito na sila 20 times 1.0032 times 573 minus 423. So ang extra heat na gina-carried away sa flue gas per kilogram of fuel is equivalent to 3009.6 kilogram per kilogram of fuel. Ito itong very simple lang kayo. Ito final answer for letter A, B, and C. So next, number 4. If an actual draft required for a furnace is 6.239 centimeter of water and the frictional losses in the stock are 15% of theoretical draft, calculate the required height in meters. Assume that the flue gas have an average temperature of 149 degrees Celsius and molecular weight of 30. Assume the air temperature is 21 degrees Celsius. So, ano siya given? Natay HA is equivalent to 6.239 centimeters. Frictional loss 15%. Itong TG is equal to 422 Kelvin to TA is equivalent to 294. MG itong 30, then MA or molecular air equivalent to 28.97. So for the solution, 1 centimeter of H2O is equivalent to 98.1 PA. Convert na to na siya. So i-multiply lang na to ang 6.239. So 98.1. Natay makuha nga 612.05 Pascal. Converted ito to kilopascal na atay 0.612 kilopascal. Next, solve na to ang density of air is equivalent to PM over RT na atay 100,001. Yeah, so atay P is equal to 101,325 times 30 and over 8,314 times 422. Other 28.97. So natay density of air is equivalent to 1.201 kilogram per cubic meter. Next, ang density sa gas, PM, RT, same lang yapon, a different M, which is 30. And the density of gas is equivalent to 0.6866 kilogram per cubic meter. Next na yun, since ato ang frictional loss is equal to 15%, minus na to siya sa 100% na tayo makuha nga 85%, which is equivalent to 0.85. So para makuha na to ato ang theoretical draft, HA is equal to 0.85 times HT. Uh, Substitute lang ang HA and then shift solve na yun para makuha na to ato ang theoretical draft, which is equivalent to 0.72 kPa. And next, since na naman tayo theoretical draft, masolve na to ang height. So HT is equal to height times density of air minus density of gas times 9.81 over 1000. Then substitute 0.72 is equivalent to H times 1.201 minus 0.866 times 9.81 over 1000. Shift solve, then ito ang final answer will be 219.0.880 meters para sa ito ang height. So very simple. So that is all. Thank you for listening. Goodbye.